Alright, so in this video we're looking at this example problem. We have a hockey puck initially sliding across the ice at 3 meters per second. It then decelerates at a constant 0.1 meters per second squared. We want to know how long it takes to come to rest and how far does it travel before coming to rest. Alright, so writing down our given information, we know velocity final is equal to 0 because it comes to rest. We know the initial velocity is 3, given in the problem. We know our acceleration is a negative 0.1 meters per second squared because it decelerates. And in part A, we want to know time because it's asking how long does it take. And in B, we want to know how far it travels, so that's displacement or delta D. Alright, so in order to find the time with the given information, because we don't know what displacement is yet, so unless you do B first, the only equation you can use is velocity final equals velocity initial plus acceleration times time. So I plugged in 0 for velocity final, 3 for the initial velocity, negative 0.1 meters per second squared for the acceleration, and t is my unknown. And I solve for time and I get 30 seconds. I then have several options in order to do part B because now I know time. So 3 out of the 4 kinematic equations has displacement in it. I chose to use the one I've written here, displacement equals v initial times t plus 1/2 acceleration times time squared. You could use, there's 2 other ones that have displacement in it, and as long as you're getting the same answer, you're okay. So displacement is going to equal 3 meters per second times 30 seconds plus 1/2 times a negative 0.1 meters per second squared times 30 seconds squared. And it gives us a displacement of 45 meters.